All right, time to get started. Thank you for coming on time. Is there any questions, any questions, any questions? There are going to be two things that we're going to do to algebraic expressions. Let's start with the harder one, which is translating them. So word problems are not difficult. They're not difficult. It's just the part, the translation part, that's difficult for people. Now, at first, we're going to do expressions, and then we're going to do statements. All right, so translate this into a number 3 less than 8. So this is not the same as a number is 3 less than 8. It's so you know what the difference between an expression and a sentence is. The same difference with mathematics expression versus statement. This is not a statement. This is just an expression. So how would you express a number 3 less than 8? So if A is 8, we should somehow land on 5. If A is 10, we should land on 7. How would we express it? No. So what's in the chat box is, this is 3 is less than 8. But that's not what is said here. It says there is a number that is 3 less than 8. Exactly. A minus 3. This is how you get, just substitute in there A equals 10. If A is 10, A minus 3 is 10 minus 3, 7. That's how you get from a number to something 3 less than a number. And notice the order is different from the English. In the English, we put that up front, 3 less than 8. This is also the same as the difference of A and 3. That is the same thing. Very good. All right, here's the next one. No is. So this is not a statement, which means you cannot use the less than or equal sign. This is just one side of an equation, so to speak. A number 3 less than the product of A and B. A number 3 less than the product of A and B. What's in the chat box is not exactly, but I'm glad. So this here is a number 3 less than the sum of A and B. This here is a number 3 less than, so this doesn't say sum, it says product. So how would you fix it? A number 3 less than the sum of A and B. So fix it. This is almost there. What does it mean, product? What operation has product? What is the product of this and that? Right. So actually, in my other class, there was something interesting. Someone thought it was division because of the word and. So let me show you something. The sum of X and Y. How do you translate that? Translate the sum of X and Y. Translate the sum of X and Y. There it is. So the sum means add. The difference of X and Y, it's very important that you understand it's in the same order, because, you know, 2 minus 5 is negative 3, 5 minus 2 is positive 3. So if you hear X first, X first. First come, first serve. So what's in the chat box is perfect. The product of X and Y is X times Y, and the quotient of X and Y is, this is the letter A, is X over Y. Again, the order matters here and here. There is an order here, but it doesn't matter. You can swap them and the answer is the same. So these are the 4 basic operations, but you see there is a noun and then of, this and that. It's very structural. Like the first thing is between the words of and and. And the other thing is after the and. It's very structural in a way. See, of X and Y. Okay, so now let's go back. A number 3 less than, we had that right. So 3 less will happen like this. This is how we get a number 3 less, by subtracting 3. And then the thing that we're subtracting 3 from is A times B, or AB. Kind of like what's in the chat box, because in the chat box there is a parenthesis around AB, which I think is I think it's reasonable, and it would be part of simplifying, not translating, to omit that parenthesis. I'm sorry. So the parenthesis can be dropped, but I think this is the better translation than this, I guess. Any questions? The product of a number 3 less than A and B. Ooh. The product of a number 3 less than A and B. Look for the first, so product means two things will be multiplied. The first thing is between the words of and end. And the second thing is after the word and. Those are the two things we're gonna do. What? The product of a number 3 less than A and B. Wow, this is gonna be some exciting recording. The product of a number 3 less. Okay, so everyone writing something. You can direct it just to me if you're shy, but everybody writing something. It's not gonna go like that. Everybody write something. Try to translate this. So let me translate what you guys sent in. So I see something like 3 less than the product of A and B. What is this that I just wrote here? 3 less than the product of A and B. That's AB minus 3, right? 3 less than what? Well, the product of A and B. That's not what's going on here. You can actually, it's very, very structural. It's almost mathematical. The product of and. So the two things that we're going to multiply is between this and that, and the other thing is going to be this. Do you care to send another guess? That's B less than the product of, oh, interesting. So keep it coming. I have not yet seen the correct answer, correct translation. So that's the one. So it basically, it says the product. So that means the last thing we're going to do is a multiplication. That's going to be the last thing that we're doing. And the product of two things. One of the things, you see, of and end. One of the things that a number 3 less than A, you know what that is. A number 3 less than A is A minus 3, and the other thing that we're multiplying is B. Get it today. If you're not, ask questions or try. It's okay to get it wrong. What's not okay is to give up and say, oh, well, just watch some videos. And no, we have to struggle through this. Okay, you see, this is the product of a number 3 less than, and this is 3 less than the product. So the last thing that happened is that minus. So this is 3 less than a product. This is the product of something 3 less than A and B. All right, let's do one more. I'm not sure if the notes will be all that good today. The sum of the square of A and B. Well, actually, I didn't read it out right. My intonation was not helpful. Try to read it for yourself. A equals B is A equals B. This is much more involved. So the sum of the square of A and B. The sum means we're gonna add. Yeah, that's what I was worried about. No, actually, we're gonna add two things. What are the two things? It's a little hazy, but it's basically A squared plus B. Also acceptable wrong answer is A squared plus B squared, because what if the square is, yeah. But I think then it should say the square of, wait, this is wrong. Oh, because I'm doing the wrong. The sum of the square of A and B is A squared plus B. The square of the sum of A and B is A plus B, the sum squared. Does that make sense? I wrote the correct answer in the wrong spot, which I guess is the same as writing it incorrectly. So A squared plus B squared is an acceptable wrong answer for for this one, because it should say the square of A and the square of B, or the squares of A and B. But I think we should be very clear. This one is, I think this one cannot be interpreted in any other way than the square of the sum of A and B. The sum of A and B, and then the square of it. It's very mathematical, basically. All right, let's do some more. This is page wrong. This is page wrong. Okay, so these are statements. So these are more complicated, but they're still structural. So let me explain myself. There are two sides, and the is the equal sign. And then this is the left-hand side, and this is the right-hand side. The is the equal sign. And so A is, and the other side is an expression like before. What is 5 less than the quotient of B and 3? How would you write that? 5 less than the quotient of B and 3. Again, a very constructive error on the board. You have to swap the two. I know it says first 5 less, but yeah, okay. So this is the quotient of B and 3, and this is 5 less than that. If you swap the two, that's very different, but this is something that I need to tell you what it is. So we're going to set this aside. We'll come back to it. So 3 less than x. Now, here is the correct translation, and here is an incorrect translation. And they are kind of symmetrical, and I want you to be able to sort out which is which. So what I want us to do is testing. We're going to make up numbers for x. Let's say x is 1, 5, 10, 20, minus 10. If x is 1, what is x minus 3? If x is 1, what is x minus 3? Thank you. Negative 2. Now let's repeat the same thing, but now x is 5 plus 2. Good. X is 10. What is x minus 3 then? We're always going to get the right relationship, because 20 minus 3 is the number 17, which is 3 less than 20. Now let's test this one. I'm going to use the same numbers, 1, 5, 10, 20, negative 10. And now 3 minus x, what is that? 3 minus 1 is 2. Oops, right away, the first pair tells you something is off. These numbers are not 3 away from each other, right? Now let's continue. What is 3 minus x is if x is 5? Negative 2. Now they're really getting far apart, right? Now the difference is 7. Okay. How about if x is 10? If x is 20, and 3 minus negative 10 is, so the difference does not work. This is incorrect. You know what this is? Add the numbers. What is 1 plus 2? 1 plus 2 is 3. What about 5 and negative 2? 10 and negative 7 when we add. This is how we write when two numbers add up to 3. Because later on, not today yet, but if you simplify x plus 3, x plus 3 minus x, you see x will cancel out. Basically, this is how you write x and x minus 3. These are two unknowns differing by 2 unknowns. Their difference is 3. 2 unknowns, their difference is 3. And this is 2 unknowns, x and 3 minus x. Their sum is 3. Okay, so this is why I didn't. 5 minus b over 3 was incorrect. You have to be very, very careful with the 5 less means to get to a number 5 less, you have to subtract 5. To subtract it from 5, you're going to get things with the same sum that way. Okay. But I think it's more important that if you're not sure, you can test your theory with numbers. Numbers are your friends. They'll never let you down. Never, ever, ever. All right, let's do one more. The sum of A and 2 is 3 greater than 3 times B. Find the is, that's the equal sign. And then two things, two creatures at both ends, both sides. Those are the left-hand side and the right-hand side. Sum of A and 2 is 3 greater than 3 times B. Almost 3 greater. So that is means equal. Just a one-to-one translation. Always, always, always. And then the sum of A and 2 is A plus 2. By the way, that is the same as a number 2 greater than A. That's the same as the sum of A and 2. Now, what is the other side? 3 greater than 3 times B. 3 greater than 3 times B. Oh, I should have said 3 greater than the product of 3 and B. This is 3 times B. Exactly. So you were almost there already. That's, guys, that's the thing that trips up people in calculus. Not, but after they set it up, they can solve it. It's just the translation. And it's so crucial. It's never going to go away. Get it today. You can all get it. All right. Next up, you're getting more involved. So this is the big separator. This is the left-hand side. This is the right-hand side. Actually, no. No, this is not. I didn't say it right. Okay, check this out. This here is the left-hand side. Left-hand side, which I'm gonna usually abbreviate like this. That's short for left-hand side. Now, this here is the right-hand side. And this is the comparison in between. This is the comparison. So this is right-hand side. So there are 3 things going on here. The is the equal sign. What's the stuff I underlined with green? The left-hand side. What's that? The difference of A and the square of B. Translate the left-hand side, which is the difference of A and the square of B. Gotta enter some, there we go. There's the correct answer. Okay, also the correct answer was there too. The difference means we're gonna subtract. The first thing is A and the second thing is the square of B, right? The end separates the difference of this and that. And so the square of B looks like this. Very good. Now skip this and then go to twice the sum of B and twice A. Ooh, twice the sum of B and twice A. Yes. So we skip this, and then after the word then, twice the sum. That's how you translate twice the sum. And then you look a sum of this and that. So you of, and this is one thing, this is the other, right? So perfect. It looks like we have the algebraic expressions department here. Good. A little chewy, but oh, we have more. Wouldn't you know? We need more too, because one person got it, but that's not enough. You won't need to get it today. The difference of 6 and x is, so the left-hand side is the thing until you hit the word is. Translate that. The difference of 6 and x, almost perfect. So what's in the chat box is almost perfect. I agree. The difference, no, wait. The difference of 6 and x, not x and 6. I have a joke about that here. With the sum, it's cool, because you're safe either way. So the difference of 6 and x is 6 minus x. that's the equal sign. And then what is half of the sum of 10 and x? Half of the sum of 10 and x. The perfect answer is in the chat box. Good. So half of looks like this. And then half of what? Half of the sum. Okay, there is a sum. Sum of what? This and that. There you go. And if you mess up the order of 10 and x, that's fine. We're safe that way. But with division and subtraction, we have to be careful to, not to swap those. Can you channel your confusion into, oh, good, it's getting better. Some people who didn't get it at the beginning are getting it now. Good. All right. Oh, this is like 5 lines. The product of 5 and a number 3 greater than a. So the product of 5 and a number 3 greater than a is 2 greater than 3 times the sum of 4 and the opposite of b. It's a lot of blocks, but none of them are really hard, I think. So the left-hand side is the stuff before the word is kicked in. What is that? It's a product. So when it's a product, you go, we're going to multiply 2 things, right? What are those 2 things? Well, one of them is between the word of and the other one is, well, until the word is, right? So one of the things we multiply is 5. And what is the other thing? What is the other thing we're multiplying? What is the other thing we're multiplying? It's after the word 5 and before the word is. Translate that into algebra. You knew that like half an hour ago. A number 3 greater than a. Are you seriously telling me you don't know? Number 3 greater than a. I'm not sure you don't know this. I think you're just not taking pity on me, but that's okay. I'm going to write your exam, so feel free to make me as angry as you can. I didn't write your exam yet. So, all right. So until the word is, which stands for the equal sign, we say the product of 5 and a number 3 greater than a. There's no way to interpret this in any other way. Okay. All right. What about the other side? 3 times. Oh, this is crazy. So the right-hand side was bad. I think it's 2 greater than 3 times sum of 4 and the opposite of b. Okay, so the first thing that you see is 2 greater than. That's how you do that, right? That's how you get 2 greater than a number. And then what's that thing? 3 times the sum of 4 and the opposite of b. That's not that bad. You can do that. So what's in the box is 3 times the difference. Oh, you're correct. You're just already simplifying it. So yeah, it's 3 times a sum of whom? Well, 4 and the opposite of b. And so what's in the chat box is already simplified. Oh, lovely. There we go. Perfect. Perfect translation is in the chat box. Lovely party. Good. You guys are getting this. Okay. The quotient of x and the difference of x and 1 is twice as much as the sum of a and the quotient of 4 and b. Ooh. Oh, okay. I just saw that you have 2 parts. So I think you might have it right. Let me go back to the paper. Sometimes it freezes when I don't see the paper. So, all right. So before the word is the quotient, okay, the quotient of x and the difference of x and 1. See, it's the difference x and 1. It's very, very mechanical. Is twice as much as the sum of A and the quotient of 4 and B. Perfect. It was in 2 pieces, but the perfect answer was in the chat box. Very good. She's getting it. And I think you caught up to it in this class, I think. This is something that you know, you just don't know that you know. All right. So we need some more. And I think I'm going to start showing them to you in pairs because sometimes that helps. Okay. So the product of X and 3 less than Y. That's just an expression, not a statement. 3 less than the product of X plus Y. Sometimes I think seeing them in pair enlighten certain things, helps you understand. I think so. So that is a pair. And what I want you to focus on is what's the difference? This one is a product. The main thing is a product, which means the last operation is going to be a multiplication. This is 3 less than something. So the last thing that you're going to do is subtract 3. And then here, the product of that word and separates it to 3 less than Y. So the product of X and 3 less than Y. And this one is 3 less than the product of X and Y. See, it's kind of, all right. Okay, so I'm gonna do something weird. I usually never share my entire desktop because hideous things that are up here, but this is the only way we can go back and forth. Okay, so here is a cute little question. Can you see it? So use X for the variable and translate the product of 11 more than a number and the number. Use X for the number and then the product of 11 more than a number and the number. Has to be X and X. So, no. Wait, you're already simplifying. So the product means we're going to multiply 2 things. And then the 2 things are, one of them is 11 more than a number and the number. Now, so I don't know if you just made a mistake or you started to work it out, but when you work it out, you get X squared plus 11X, not X plus 11X. But we're not, so there are 3 things that we can do to algebraic expressions. Number 1, translation. Number 2, evaluate it. And the last thing we're gonna do is simplifying. That's the hardest one. All right. Next up, use X for the variable. What is the product of 17 more than a number and 11 more than the number? Oh, it just occurred to me that X plus 17, you just swap them, don't you? You get away with addition. Okay, let's see the next one. The square of the sum. That was fine. The square of the sum of a number and 9. The square of the sum of a number and 9. You guys have an agreement, and it's the correct answer too. Lovely, lovely coincidence. X plus 9 squared. And what would this be? Translate it back to English. What is this? Translate this back to English. No, that's kind of the point. That it's the sum of the square. It's an order of operations thing. Here, the square of the sum. You add first, then you square. Here, the sum of the square of x and 9. The sum of the square. You see that? Of x and 9. And if you want to put a square, then it should say and the square of 9. You see the difference? This is a sum. This is a square. It's basically the last thing that happened. I guess you just include order of operations in the way you say it. Never thought about it that way, but yeah, that's what it is. There is an order of operation in the English sentence structure too. Okay, let's see the next one. 17 less than the quotient of a number cubed and 11. 17 less than the quotient of a number cubed and 11. 17 less, we achieved that by subtracting 17. From what? Well, it's 17 less than the quotient of something and 11. What's that something? A number cubed. There. Cube means raise it to the third power. Okay. These are going to be sentences. So statements. The sum of 3 times a number and 6 is 9. Translated. These are statements. Okay, so is 9. Something is 9. What is 9? The sum of what? 3 times a number and 6. Yep, okay. All right. There 3 times x plus 6 equals 9. Okay, next up. The quotient of 4 more than a number and 7 is 10. Yeah, you're getting it. The quotient of 4 more than a number and 7 is 10. The quotient of 4 more. 4 more means not 4 times as much. See, 4x is 4 times the number, or the product of 4 and x. 4 more is just an addition. And then you have to be careful, the quotient of, so check this out. Translate these two. There is an interesting little message about how these two are different. So if you could please translate them back to English. Thank you. These two. So the word is should not be there because these are not equations. The is stands for the equal sign, basically. So 4 more than the quotient of 7, that's this. Excellent. This is 4 more, or the sum of 4 and the quotient of x and 7. 4 more than the quotient of x and 7. And what about this? Oh, there we go. And the second one is a quotient of what? 4 more than a number and 7. So this here is the quotient of 4 more than a number and 7. Now, this is interesting because order of operations says in here and in here that we have to first add 4, but division is stronger. So when you have a division sign stretching below an entire expression, that's what I call a case of the invisible parenthesis. So when you enter it, you have to enter this into the calculator too. Otherwise, you're going to enter x plus 4 over 7 without a parenthesis is really this. And that's important when you enter something into the parenthesis. It's not a mind reader. It will do exactly what you tell it, not what you mean to tell. Okay, so going back, what do we have here? The quotient of 4 more than a number and 7 is 10. Which one is correct for the left-hand side? The first one or the second one? The quotient of 4 more than a number and 7 is 10. It's this one, right? X plus 4 over 7 equals to 10. Right? The quotient of 4 more than an, oh, the quotient of 4 more than a number and 7 is 10. Okay. All right. There it is. Yeah. So on paper, you should do this. If in the chat box, and more importantly in the calculator, you have to put the numerator into parentheses. All right. Next up, the product of 4 more than a number and 9 is 15. That sounds easy. We had seen much worse. I'm just writing this down. So first of all, you have some time to think about it. Plus the notes are not going to be completely gibberish. But feel free to translate it while I'm writing. Product of 4 more than a number and 9 is 15. I think the correct answer is in the chat box. So the product of two things. What are those two things? 4 more than a number is indeed x plus 4 and 9. And then we already know that we don't need the parentheses. Equals to 15. Excellent. 9 times x plus 4. See, these are the little habits. This is actually wrong. What's here? Because what's in the box is the good answer for the product of 9 and 4 more than a number. We are just in this habit that whenever we have multiplication, we like the shorter stuff up front. So this is an incorrect. Who wrote this problem? I did. I have to fix this one. This is wrong. Okay. You see, because the correct answer, the more correct answer is in the chat box. It's x plus 4 times 9, not 9 times x plus 4. Interesting. All right, next up. The difference of a number and 6 is 12. The difference of a number and 6 is 12. Yes, and you got it in the right order. The difference of a number and 6 is x minus 6, and that equals to 12. Okay, good. Oh, excellent. Next up, 11 less than the difference between a number and 3 is 15. 11 less than the difference between a number and 3 is 15. Wait, no, this is fine. 11 less than the difference between a number and 3 is 15. 2 correct answers in the chat box. Excellent. Oh, I forgot to write it down. Perfect. 11 less. Okay, I'm gonna. There it is. Lovely. Lovely. Okay. Difference. Sorry. If I'm gonna push next, we'll never see that one again. Difference of a number. So translate that. The sum of 2 times a number and 5 is 8 times the number. Difference of a number and 3. The sum of 2 times the number and 5 is 8 times the number. Yep, correct answer is in the box. 8 times the number. So the sum of 2 times the number and 5 is 8 times the number. I'm not sure. How do you feel about the dot? It's harder to read. It's harder to, that's why it's good to have multiplication denoted by just nothing. All right, good. Next up, the sum of 4 times the number and 7 is 10 more than the number. Okay, the sum of 4 times the number and 7 is indeed 4x plus 7. Is 10 more than the number is indeed x plus 10. I agree, and so does my open math. No, it says 10 more than the number. Again, this is wrong. 10 plus x is not, technically speaking. Wow, these, you need to work on these questions. You guys are answering them better than I do. Okay. All right. Any questions? Okay, we need to stop here because the people who are not getting it are not even trying. And the people who got it already, they're going to get bored. So no one is getting served by if we continue with this. But you should go after this because without this, STEM is not going to work. This is, you're going to see all kinds of word problems, but the difference is only in the difficulty level of the thing. The translation is algebra 1, right here, right now. And that's never changes. That's the same in calculus. So the other thing that we can do to algebraic expressions is evaluate them. Now, we cannot evaluate this expression because we don't know what A and B are. So these problems will always continue and say if A is -2 and B is 4. And so here is how you do it. At least at first. First, write down the entire line as it is with one exception. Replace the letters with cute little pairs of parentheses. So instead of A, we're going to write a cute little parentheses. Instead of B, we're going to write a cute little pair of parentheses. Plus 3 times, instead of B, like so. And then copy the values. A was -2, B was 4, B was 4, A was -2. And now it became an order of operations problem. Which you know. So simplify this order of operations problem. Let me tell you when you need the parentheses. You're always going to need the parentheses if the number substituted is negative. And you're never going to need the parentheses if the number substituted is positive, but you have to write not 34, but 3 times 4. So it's up to you whether you use the parentheses, but you will always need parentheses if that number is negative. Always, always, always. So let's see, what's the first thing we do here? Exponents first, excellent. So no one fell into the trap of reading the parentheses as grouping symbols because none of them are. So you're right. First, we have to do -2 squared, which is 4. This -1 multiplier is just waiting. There are really 3 negative signs here, not 2, right? Because this one is squared. Plus 3 times 4. It's up to you if you preserve the pair of parentheses or just go with the dot. And eventually you can go with the dot on the first line. All right, what's next? There is no parentheses. No, I mean, there is parentheses, but there is nothing to do inside. What inside? There's just, this is not a parenthesis that is a grouping symbol. That's just, that's what I call a clarifying parenthesis. It just clarifies that, right, multiplication, but this one comes first, left to right. I guess, is it -4 times 4? Well, either way, it's -16 plus 12 plus 4 plus 8, right? And this is 0, so this is 8. And the thing is that different values of the variable, this expression has different values. Evaluate -x squared plus 3x plus 7 if x is -4. So we substitute -4. I'm getting -21. Do you? Okay, good. Okay, 1 greater than 3 times x is a factor of 21. So you will see that this statement is called this statement is called a conditional statement because sometimes it's true, sometimes it's false, depending on the value of x. For example, if x is 5, Is this statement true? No, because 16 is not a factor of 21. What about if x is 2? Yes, 7 is a factor of 21. So when you have one value for yes and one value for no, that's a conditional statement. The truth value, whether the statement is true or not, depends on conditions such as what is the value of x. So yes, 7 is a factor. In fact, there are 3 types of statements: the ones that are always true, the ones that are always false, and conditional. Most of the statements you will see are conditional. Okay, so here is another conditional. So this is a conditional statement. This here is a conditional statement. Its truth value. Truth value is fancy for whether it is true or false. This truth value depends on x. Okay, so now I'm going to show you an equation. X cubed minus 5x squared minus 5x plus 2 equals to minus 6x squared minus 3x plus 2. It is intentional that this is an equation you cannot solve into your head. You cannot solve it in your head. That's intentional. Because what we're going to practice now is checking if a number is a solution of an equation or not. So a solution is a number that makes the statement true. This statement, that those two are equal, makes the statement true. So I want you to evaluate the left-hand side. This is going to be short for the left-hand side is what if x is 1. What is the left-hand side of this equation if x is 1? It's zoomed in. This is so big. It's not zoomed in. What is the value? Evaluate the left-hand side if x is 1. 1 is one of the easiest numbers to substitute there. I'm getting -7 as well. We have 1 cubed minus 5 times 1 squared minus 5 times 1 plus 2. And that's 1 minus 5 plus 2. That's basically -10 plus 3, right? -10 plus 3. That's -7. I didn't use order of operations. I gathered the positive ones and the negative ones. Okay, what about the right-hand side? Right, so if x is 1, that side too is -7. We have, sorry, -6 times 1 squared minus 3 times 1 plus 2. It's -6 minus 3 plus 2. -9 plus 2 is -7. So what this means is that -7 is a solution, not the solution. There are 2 other numbers. There is one very easy. Just look at this and evaluate it with 0. If x is 0, both sides are exactly +2. So it's not the solution, it's a solution of the equation. A solution is a number that makes the statement true. Wait, not -7. 1. 1 is a solution of the equation because it makes the statement true. That statement is -7 equals -7. x cubed, what is the equation? X cubed minus 5x squared minus 5x plus 2 equals minus 6x squared minus 3x plus 2. That statement becomes -7 equals -7, and that's true. Sorry. Okay, well, how about +2? If x is, the equation is here, hopefully it's readable. Getting good. What about if x is 2? What's the left-hand side? What's the right-hand side? Oh, I'm getting -20. Did I mess up? I probably did mess up. -5 times 4, -5 times 2. Okay. Right-hand side. If x is 2, -6 times 2 squared minus 3 times 2 plus 2. So when x is 2, the two sides are not equal, right? When x is 2, I'm sorry, I need to write it. Sorry. When x is 2, then the statement x cubed minus 5x squared minus 5x plus 2 equals minus 6x squared minus 3x plus 2 becomes -20 equals -28. That is a false statement. And so we say that 2 is not a solution of the equation. But 0 is, if you substitute, 0 is really lovely to substitute. Everything that has x disappears and you get 2 equals 2 if x is 0. And there is a third one, and who knows, just check it out if x equals -2. Left-hand side, right-hand side. We didn't do -2, we did 1 and 2. So the equation is still here. Substitute x equals -2 into the left-hand side and the right-hand side. The goal is to determine whether x equals -2 is a solution of the equation or not. I agree. Left-hand side is -16. Notice I'm violating order of operations left and right. It's not an order of operations problem where you have to demonstrate you know the order of operations. Here, you can, if you know you get away with it, you can get away with it. What about the right-hand side? I'm getting -16 there too. So -2 is also a solution. 1, 0, and -2, all three are solutions. That can happen to an equation if it's high enough degree. We have -6 times -2 squared minus 3. So that's -6 times 4 plus 6 plus 3. -24 plus 8, which is -16. So x equals -2 makes the equality statement true. So x equals -2 is a solution. So you see, trial and error will never, well, first of all, this is how we check. We're gonna deploy systematic techniques to solve equations. To solve an equation means to find all the numbers that make both sides equal. And so the problem with trial and error, you never know when to stop, right? Did you find them all, or there is 3 more numbers out there? So to solve an equation or an inequality or anything, pretty much, to solve an equation or inequality, we have to find all solutions. It's going to be called the solution set, little set theory there. We have to find all solutions. And many times there is going to be infinitely many badly. Like, check this out. 3a minus 1 is less than 5a. Oh, 5. That's the whole point. 5b plus 2. Now, this has 2 unknowns in it. So a solution would be a pair of numbers for a and b that makes this true. So is a equals 2 and b equals 3 a solution, that pair? Well, the left-hand side is 3a minus 1 is 3 times 2 minus 1, that's 5. And the right-hand side is 5 times 3 plus 2, which is 17. So if a is 2 and b is 3, then 3a minus 1 is less than 5b plus 2 becomes 5 is less than 17. Is that a true statement? Yes. So this pair of numbers, and sometimes you will see not a pair of numbers, but ordered pair of numbers. Because if a is 3 and b is 2, that might be a different scenario. That's true. So a equals 2, b equals 3 is a solution of the inequality. And there, I think you fix one a, and there are infinitely many b that work. So it's like doubly infinite. And then you can change a, and so infinitely many solutions doesn't describe it enough, how many solutions of the inequality. But we can find numbers where it doesn't work. I guess we just, how about a equals 10 and b equals 1? That should not be a solution, right? What is this inequality become if a is 10 and b is 1? Oh, yes. So then 3a minus, if a equals 10 and b equals 1, then 3a minus 1 less than 5b plus 2, that statement becomes, I think you're right, 29 is less than 7. Is that a true statement? No, that's a false statement. So a equals 10 together with b equals 1 is not a solution. And I think it's good that I mentioned that this is an ordered pair of numbers, because if a is 1 and b is 10, that will be a solution. Ordered pair of numbers. And there are a gazillion solutions of this. We're going to have to develop, sometimes the solution set is so big, we're going to have to develop new ways of describing things because the solution set is so big. Like this one is pretty tricky. Yep. That to describe exactly what works and what doesn't is going to be pretty tricky. Okay. Any questions? Okay. most equations, and by the way, equations is the most central mathematical tool, not just in mathematics, but in economics, physics, biology. Basically, equations is the most used mathematical tool. And so most equations and inequalities are conditional. It means there are values for which it's true, there are values for which it's false. But not all. And sometimes walking into an equation, you don't know what is what. You don't know whether. Now let me show you equations that are not conditional. If it's not conditional, then it's either always true or always false. These are the three types of equations. Not conditional. Now this sounds really silly, but how about a plus b equals b plus a? Now, I think you have a hunch that no matter what we substitute, it's going to say 2 plus 3 and 3 plus 2, same thing. See, this one, any pair of numbers you can think of will be a solution. Such an equation is called an identity. So all pairs for A and B are solutions. And such an equation has a name, it's called an identity. And we need identities because you know what, this statement is not about numbers. This statement is talking about the property of addition, right? That for all A and B, it doesn't matter what order you add them. You can swap two numbers around in addition and it won't affect the result. Subtraction, division, that's a different story. But you see, this statement looks silly until you realize we're not just talking about numbers. Sometimes we want to talk about the operations. This statement is basically, if we say for all A and B, A plus B equals B plus A is the same as to say that addition is commutative. Just imagine you have the plus sign and 2 and 3, and imagine that you start revolving or commuting these around the plus sign. They freely commute and it doesn't affect the answer. Now, there are also unconditionally false statements. Something like x plus 1 equals to x plus 3. No number does that. This is always too bigger than this, right? No number does this, but it's not so easy to see than this one. Maybe it's a little bit less intuitive. This is always false. And such a statement, such an equation is called a contradiction because the two sides contradict each other. But as I said, most of them are conditional, but we don't even know which one we are dealing with until we simplify and we get something pretty basic so we can use our intuition to decide what is what. Any questions? All righty, then I'm going to stop here. Thank you, guys.